So, welcome to the first video in Module 3 where we do graph analysis. And as promised, I have to apologize for the bad pun, but we're talking of how to get from one node to another node. And we look here into connectedness, how two nodes are connected. Because some nodes may be or may not be reachable from other nodes. So if a node is not connected to the other nodes at all, so has zero connections, we talk about a dangling node. I used that previously in different videos already, but want to introduce it here formally. So a node without any edges is a dangling node. Connected nodes is what the word says, connected to another node. So they have edges and they can be reached from another node, and not specifically from every other node, but from at least one other node. And the path that we take from one node to another, we consider that a walk. So those things are really, really simple to memorize because, well, you walk from one node to another, and that's the path you take. So quite straightforward. And in a similar hiking idea, we also talk about distance from a geodesic perspective. We can measure how connected two nodes are by how far apart they are in a graph. So we can calculate that by counting the edges in the shortest path between two nodes. So how many other nodes you have to pass until you get to your final destination. We save this as a distance, which gives us the distance between two nodes, Vi and Vj. Which one these are? Well, you pick it. It depends on the problem you are analyzing. And if they are not connected, those nodes, we have a distance of infinity. So the statistics that we use quite often is based on the distance by all the nodes together. So if you consider the mean distance of all the nodes and you have a dangling node, your average, of course, is infinite. That is a problem. That makes it meaningless. If you take the median, again, you have a median distance. So it depends on the problem on hand, which measurement of geodesic distance to describe the whole graph you're actually using. Another concept that is quite straightforward here to introduce is the idea of neighbors and second neighbors. Well, if you think of it in real life perspective, your neighbor is the person who lives directly next to you. Same in graphs. One node connected to exactly the other node without any nodes between are neighbors. If you have to cross one node as well, you have second neighbors. And you can play this game up until you have fifth neighbors or something like that, where you have to cross 4 other nodes to reach your final destination. And so from that perspective, neighbors are exactly what they are. They are next to each other.